Good afternoon, everyone. Now I introduce the article, a study on application of medical vector organism based on improved transformer. Accurate and timely identification of medical vector organisms at ports of entry and exit is an important issue in the work of customs and exercise department. Among them, flies, mosquitoes, and cockroaches are important parts of vector organisms. Therefore, it is a meaningful task to conduct research on the identification of vector organisms at ports of entry and exit. The traditional measures mainly rely on the experience accumulated by the staff in the actual identification work, which requires the staff to match the physical and morphological characteristics of the vector organisms distinguished by the naked eyes, always the help of microscopic magnification equipment, or with the descriptive text in the books on species classification, which is very much dependent on the practical experience of the staff. However, due to the large number of vector organisms, some vector organisms have similar apparent characteristics, and the staff are not all experts with rich practical experience in identification, relying only on the staff's experience to determine the types of vector organisms, especially in the initial screen stage of the sample size large. There is a slower speed for real-time and subjective so that the impact of the fresh sample morphologic identification of the detection of the problem of the initial screen, making this method very time-consuming and labor-intensive. In this paper, we use three sets of network models with exactly the same network structure. The number of transform layers is 243. The dimensions are 64, 80, 96, and finally a group of points of point convolution is performed to reduce the feature map. The overall architecture in the model is shown in Figure 1. The network structure is shown in Table 1. Only the input dimensions of transformer are different from sub-VIT input. The input token is 64, 80, and 96. Improved satellite structure schematic is shown in Figure 2. In contrast, the ILU6 activation function is limiting the ILU function to a maximum output value of 6, which allows for excellent numeric resolution on low precision devices. When the ILU function is not limited to a maximum value, it will not be able to accurately characterize a large range of values on low precision devices, resulting in a loss of accuracy. The use of the H-switch activation function reduces the number of parameters compared to HLU6 and H-switch. Each pixel operates yet attentively only with the other pixel in the same position. The number of sequences formed in the pixel value of each block, assuming that the width, height, and the number of channels of the feature map are H, W, and C respectively. Then the number of sequences in each sequence is W multiplied H divided by P, and P is the size of the block. Transformer operation is performed on the model after obtaining the sequence. In this paper, we use a dataset which contains 3 species of cockroaches, 6 species of mosquitoes, and 20 species of flies, with a total of 338 image datasets, and the background of the images is a single unobstructed environment in the laboratory, where the various categories of vector organisms are displayed in the form of p-inserted specimens. The dataset suffers from uneven distribution of the number of images in each category and the differences in angle of vector organism display. with the number of sample images in each category ranging from 9 to 53. Pick file shows the main categories of the dataset displayed. The results in Table 2 show that ShuffleVIT outperforms other convolutional neural networks. For the ResNet series of convolutional neural networks, ShuffleVIT outperforms ResNet 18 by 1.33%, ResNet 34 by 1.03%, and ResNet 50 by 1% in the accuracy of the image classification task. For the MobileNet family of convolutional neural networks, ShuffleVIT outperforms MobileNet V1 by 4.03%, MobileNet V2 version 1 by 3.24%, and MobileNet version 2 V2 version 2 by 1.58%. MobileNet V3 large by 2.31%, higher than the MobileNet V3 small, and 5.45% higher than MobileNet V3 small. For the ShuffleNet family of convolutional neural networks, ShuffleNet VIT is 12.83% more accurate than ShuffleNet V2. The article proposes a new low-weight image classification network model for vector organism recognitions. Firstly, a fusing model is introduced to replace the depthwise separable convolution in the sublet with a regular convolution 3 multiply 3, and each switch is used to replace the ILU activation function, which reduces costs while better reducing the number of model parameters. Then this article uses a network architecture that combines convolution and improved transformer to input images in sequence into the transformer to obtain global feature information, ensuring that the network model can extract local and global features of the image. At the same time, the transformer is improved to reduce the number of model parameters. That's all. Thank you for listening.